So we are dealing with the eighth problem over here, and this is from paper 1, problem number 8, JEE Advanced 2025. A person sitting inside an elevator performs a weighing experiment with an object of mass 50 kg. Suppose that the variation of the height y in meters of the elevator from the ground with time is given by the expression 8 1 plus sine 2 pi t by capital T, where capital T is 40 pi second. Taking acceleration due to gravity as 10, the maximum variation of the object's weight as observed in the experiment is. So we need to calculate the variation in the object's weight. So for variation in the object's weight, we can say that if the consider that the acceleration is in the upward direction, then over here we can say something like this, that the weight mg will be in the downward direction and ma in the downward direction. So the weight will be recorded as the normal reaction force. So in this scenario it will be n1 is equal to mg plus ma. Now in the second scenario we can say that if the acceleration is in the downward direction, then we will have a pseudo force ma in the upward direction, gravitational force mg in the downward direction, and the normal reaction force n2 in the upward direction. So n2 will be written as mg minus ma. So if I say something which the problem is asking us to calculate, that is the variation in the object's weight. The variation in the object's weight can be simply because of mg plus ma minus of mg minus ma, that is twice ma. So this is the variation which we are looking for. Now the only thing which we need to do is to calculate the maximum magnitude of acceleration, because the problem is asking us for the maximum variation possible. And for that we have this expression. So we have this expression as y is equal to 8 plus 8 sine 2 pi by capital T times t. So we have this equation. So if we write velocity, then we can write it as dy by dt. So for dy by dt the constant is equal to 0, and 8 then omega 2 pi by capital T, derivative of sine is cos, so cos 2 pi by capital T times small t. And then if we write acceleration, then acceleration is equal to dv by dt. So for dv by dt we say derivative of cos is minus sine, so minus 8 and then omega out, so we get 4 pi square by t square, and sine of 2 pi by capital T. So this is the expression that we have. So maximum magnitude of acceleration which we have, magnitude will be 8 times of 4 pi square by t square. So t square over here is 40 pi, so we can say 40 pi times 40 pi. So this is the equation that we have for maximum magnitude of acceleration. And if we solve this, pi square gone, 8 times 5 and 4 10, so we get 1 by 50 meter per second square is the maximum magnitude of acceleration. So over here, therefore the variation in weight which we are looking for, delta w, which is equal to twice of ma. So the mass of the experimenter or the person over here is 50 kg. So twice 50 into 1 by 50, so we obtain 2 Newton. So for this particular problem, the correct answer is 2 Newton.